Hi, Assalamualaikum and a very good morning to my beloved lecturer and friends. First of all, I would like to thank our beloved lecturer, Puan Noria binti Johan, for giving us the chance to be here today. It was such a great pleasure for us to be here today to discuss the topic that we have prepared to present to all of you. And before we start our presentation, allow us to introduce ourselves first. Starting with me, my name is Nur Atira binti Razali and my matrix number is 01DKA2A F2002.
My name is Eli Adliza binti Jafridin. My matric number is 01DKA20F2011.
My name is Muhammad Azim Muhammad Izal. My matric number is 01DKA20F2025.
My name is Nura Amakis binti Muhammad Nazan. My code number matric is 01DKA20F2023.
Hi everyone, my name is Nur Nabiha Uzman binti Yuhazri. My matric number is 01DKA20F2032.
Here is some of the content that we're going to discuss today. Please stay until the end of this presentation. Okay, so the first thing that I'm going to discuss with you today is the introduction and the theory of traverse total station. Okay, what is traversing? Traversing is a sort of survey in which the framework is made up of a series of connected survey lines, and the direction and length of the survey lines are measured using an angle measuring device and a tape or a chain respectively. Traverse total station is divided into two types, which is closed traverse and open traverse. Closed traverse applies when the line creates a circuit that terminates at the beginning of location, while open traverse applies when the line forming a circuit terminates somewhere other than the beginning of the location. Next, I'm going to share with you the theory of traverse total station. Traverse total station connected survey lines from the framework and the directions and length of the survey lines measured by angle measurement instrument and a tape. When the lines form a circuit which end at the starting point, it is known as closed traverse. If the circuit ends elsewhere, it is said to be an open traverse for the survey of larger area, whereas open traverse is suitable for surveying a long narrow strip of land as required for a road and the other things. The main principle at traverse is that a series of straight lines are connected to each other and the length direction of each line is known. The joints of 2 points of each line is known as traverse station, and the angle at any station between consecutive traverse legs is known as traverse angle. After that, I'm going to discuss with you about theodolite traversing. It is a method of establishing control points. Their position is being determined by measuring the distance. It is between the traverse station and the angle subtended at the various station. The length between two stations is measured directly by chaining or taping in the ground. That's all from me. Next, I'm going to pass this presentation to Eli Adliza.
Thank you, Nur Atira. Hi everyone, my name is Eli Adliza binti Jafridin. I will be continuing this presentation. The first thing I would like to talk about is objective. Objective. Total station traversing is one way for obtaining horizontal surveying control. We traverse in order to provide a single system of control point on a map. When we need to design a construction detail, such as a site, the control point of traverse may be used to define the center point of a road, buildings, and so on. Total station traversing, which is horizontal control of surveying, can achieve the following goals. Number 1. To understand how to correctly position the total station in the operating sector. 2. To learn to utilize the total station and appropriately get readings. 3. To determine the internal angles of the working sector. And 4. To be able to enter data into a table. 7. To theoretically compute and observe angle discrepancies. 8. To compute the traversal point's coordinate. 9. To move bearing on each pointing station in the opera sector. 10. To be able to correct any station that has been pointed out. And last, to calculate the mean angle and misclosure. Next, I will be explaining about equipment. The first equipment is total station. Total station is a tool that is used to measure the height of distant places in respect to a reference point, a point for which the height above sea level is accurately known. It comprises of a telescope placed on a tripod and equipped with a spirit level. The next equipment is theodolites. A theodolite is an instrument for measuring both horizontal and vertical angle. As used in triangulation network, it is a tool used in surveying and engineering industry, but theodolite has been adapted for other specialized purpose as well. The next equipment is prism. Optical survey prism are a type of retroreflector, especially a corner reflector, used to reflect the electronic distance measurement, which is EDM, beam from a total station. The EDM beam is reflected back to its source by a survey prism with a broad angle of incidence and great accuracy. Next is tripod. A surveyor tripod is a device that supports theodolites, total stations, levels, and transits, among other surveying equipment. Prismatic compass. A prismatic compass is a navigation and surveying tool that is widely used to determine the bearing of the traveling and the angles between them, waypoints, cross endpoints, and direction. Next is hammer. Hammer are used for a wide range of driving, shaping, and braking application. The use of hammer in the survey is to plant a picket into the ground to be used as a sign. And the last equipment is picket. A picket is a point stack that is typically driven into the ground to hold a fence, secure a tent, tie animals, mark location in surveying, or act as a defense when pointed at the top. That's all from me, thank you.
Field work procedure.
The first step is reconnaissance. We went to the field and inspect the entire region and determine the best course of action. The next step is the selection of travel station. After we choose the best station on the level and firm grounds, we mark the area with picket.
The third procedure is linear and angular measurement. Distance between stations are measured using a tape or chain, the tachyometric technique or EDM device such as geodemeter or distometer. And the last procedure is plotting of travel survey. They were plotted into two methods, which is distance and angle method and coordinate method.
Okay, I will explain you about data collection, analysis, and data calculation. Okay, for our first slide is you can see is our diagram. This diagram is using a traverse method, and we calculate using latitude and departure method. Okay, over here you can see this diagram we have a bearing, distance, and line for this traverse method. And for the next slide is our table. Okay, our table, the first line is UT, and for the distance is 364.55, and then for the bearing is 258.3422. Okay, for the next line is TS, and then for the distance is 347.00, and then for the bearing is 309.0538, and then for the next line is SV. For the distance is 292.94, and then for the bearing 602126, and for the last line is VU. For the distance is 472.74, and for the bearing is 128.0444, and then I will total out for the distance. Our total of the distance is 1477.23. I will explain you about analysis and data calculation. Okay, for the first slide you will see the book for the latitude and departure. Over here is a handwriting one, and for the next slide we have a table for latitude and departure method. Okay, over here for the latitude and departure method, for all the column you will have line, bearing, distance, latitude, depart, correction, and coordinate. Okay, how to fill it is, for the line you will fill the first one is V, and then U, T, S, V, and then for the bearing, for the U bearing is 258.0422, and for the T bearing is 309.0538, 0538. For the S is 602126, and for the V is 1280444. Okay, and then for the distance is 364.55. For the U, and for the T 347.00, and for the S 292.94, and then for the V is 472.74. Okay, and then how you want to calculate for the lattice and dipad? Okay, we have a formula for this. The formula for lattice and dipad is, for lattice is distance cos bearing, and then for dipad is distance sine bearing. Okay, how you calculate it? For the U is 364.55, and then plus cos, and then for the bearing is 2580422. You will get, for the lattice is negative 72.226. Okay, and for the T, SV, same method. For the T, you will get 218.816, and for the S, you will get 144.885, and then for the V is 291.560, and then you total for the north and total for the south. You will get, for the north is 363.701, and then for the south you will get 363.786. Okay, same method for the dipad, just the difference is the sine cos. Okay, for the formula is distance, sine, and bearing. Okay, how you got, for example, for the U, for the distance is 364.55, and then plus sine, and then type the bearing. For the bearing is 2580422, and then you will get, for the answer for the dipad is 357.324. is get a negative, and then you will put the column of the negative. Okay, same method for the T, S, V. For the T is, you will get a negative 269.311, and then for the S, you will get positive, and then you will get a 254.602, and then for the V, you will get 372.123. You total for the positive one and the negative one, or east or west. For the east is 626.725, and then for the west is 626.635. Okay, and then how to get the difference lattice and for the different dipad? Just minus the north and the south for the lattice, and then for the dipad just minus east and west to get the answer. For the lattice difference, lattice is, you will get 0.085, and then for the dipad you will get 0.09. Okay, for the correction, the formula have been given. For this formula, the formula is distance of line divided by total distance multiplied by difference for lattice or diameter. Okay, for the correction for the lattice first, you will get negative 72.205, and then for the T is 218.836, and then for the S you will get 144.902, and then for the V you will get negative 291.533, and then you just total up all the answers over here, and then you will get the answer is 0. Okay, And then for the picture is same method like latitude, distance of line divide by total distance and then multiply by difference departure. Okay, and then you will get the answer is 357.346. And then for the T is 269.332, and then for the S is 254.584. Right, and then for the last one is V, you will get 372.094, and then you will get the same answer like latitude 0. And then for the last one column is coordinate. Coordinate, you can put anything area have been given for the question. Like say I put 1000.00. Alright, how to get? Just follow the correction. If have negative, just minus. If have positive, just plus it. Okay, for example like 1000.00 minus to 72.205, you will get 927.795. And then the same method will continue, and you will get 114.6.631. And then you will get, for the next one, you will get 1291.533. And then the last one, you will get 1000. The same, the first column you get. Same method for this one, for the west and east. Alright, I will take for example like 1000.00 in the question if given. Okay, for same method, if the picture column for the U, if you get positive, just plus it, and then you will get 1000.00 plus 357.346. You will get 1357.346, and then continue, and then you will get 1629.678, and then you minus it with 254.584, and then you will get 1372.094. And then the last one you will minus with 372.094. You will get 1000. Okay, next slide. I will tell you over here. You can see my formula and analysis for the latitude and departure. How I get the answer for latitude and departure. Over here you can see the table. Okay, I will tell you how to calculate the linear mean closure. Okay, for the formula is square root different latitude power of 2 plus different departure power of 2, and then you divide by total distance. Okay, how to calculate it is power of root 0.085 power of 2 plus 0.09 power of 2. You will get the answer is 0.12379 for 184 meter. And then for the pre-section is enclosure divided by distance, like this, 0.123794184 divided by 1477.23, and then you will get the answer is ratio. You will get 8.380 multiplied by 10 power of negative 5. Ratio 8, we will get 1:11932.95155. Okay, that's all from me. Thank you very much. I will pass to the next presentation.
Conclusion. The end of chapter, we will be able to describe the various components of the light. We understand how. First, to understand and describe close traverse survey. Example of two station, tripod, prisma, prismatic. Besides that, we know how to determine the final bearing by using suitable method. Second, we we have a knowledge of all the equipment required to carry out, and then we know the advantages of bearing and their use in various survey works. Third, we are to be familiar with the checks and error in a closed traverse and solve them. We are also to be familiar with various types and methods of traverse surveying for detailing, and we are know well about the traverse computation and be fluent in it. Fourth, we also be able to read, carry out, and reduce closed traverse, and then we get the basic principle of traversing and the experience of the fieldwork procedure, so that we able to establish the control point by surveying approach with minimized error and practicable. Furthermore, we obtain develop skill in using total station, thus could be explore more function that exist on the instrument. Fifth, finally, we get to know or understand collimation error and how it can be corrected.
Balancing a closed traverses. First, compute the sum of the measured into angle and balance them. Balancing is done so that their measured sum equal the true geometric sum of intro angle. As for a polygon width and side given by S equal 180 x bracket and minus 2 bracket, if the sum of the measured angle is different from S, then they must be balanced, usually by adding or subtracting the discrepancy to one or more angle. Second, compute the latitude and departure of each of the courses. Latitude is the orthographic projection of the courses onto the n minus s axis. Departure is the orthographic projection of the courses onto the e minus w axis latitude. Third, label each north latitude and its departure positive and each south latitude on with departure negative. Fourth, determine the error of closed in both latitude and departure and the linear error of closed. Fifth, determine the ratio of error and compare with the allowable ratio of error. First, compute the total distance around the perimeter of the traverses, then compare with the allowable linear error of closing. 6. Compute the correction in latitude and departure using the compass rule. If error is allowable, we state the correction in the latitude bracket departure bracket of a courses in proportional to the total error in latitude bracket departure bracket as the length of the course is to the perimeter of the traverses. 7. Subtract the correction in latitude and departure of each line from the latitude and departure of that line to obtain the adjusted latitude and departure. Be sure to verify that the correction result in a change in the correct direction. The sum of adjusted latitude and should equal 0 as should the sum of adjusted departure. And the last, compute the total latitude and departure around the course. If the coordinate of the initial point are known to some reference grid system, they may be used. Otherwise, assume the initial coordinate to be 0, 0.
Okay, next, I'm going to share with you the effectiveness of the team members and our mission goals. Each of us presented a document for the team to check the current meet and distribute it as a minute of meetings. The team members were very helpful and responsible. They played their role very well. We discussed the questions and the calculation and we solved it together. As far as I can say that our mission goal was a big success.